Okay, so just kind of reviewing one detail, or one typical thing that happens when you want to find a domain, and this is going to be very important when you get into rational functions and polynomials, the things that we're talking about. Now this is what you call a rational function. You don't have to remember that name. Let's say we have this function. We want to find the domain. Okay? Well, what's the restriction on the domain?
The zero.
You know, I'm gonna lump all this together. It's not a rational function anymore because we got a square root here. Okay? But I'm going to include this. Okay? So what are the restrictions on the domain? Well, the square root only works on non-negative quantities, right?
Mm-hmm.
So x minus 5 can't be negative, meaning it has to be greater than or equal to 0. So that x has to be greater than or equal to 5. Okay?
Mm-hmm.
So the domain excludes values of x which are less than 5, right? Okay? Now, the other restrictions, and I'm going to change a couple of these. I'm going to change at least this number. Okay? And I'm going to change that to a minus. Because in putting this on here, well, you'll see what happened because it's going to happen to this one, and you'll see why it would have happened to this one. So now you have no idea what I just said, but let's just go. Okay? So, we don't even consider values of x that are less than 5 because we can't put them in here.
Right.
Okay? Another restriction. The denominator can't be 0 because you can't have division by 0. Okay? So what do? We solve the equation 2x minus 14 multiplied by 3x minus 7 equals 0. And exclude any solutions from the domain. Okay?
Okay.
Well, let's write down the equation again. Okay, how can this equal 0?
The x left equals 0.
The what?
One of the x's.
Well, if the x value is 0, neither of these is going to be 0, right?
Right.
Okay, remember we said last time, I got a number in this hand, or some
Yeah.
expression in this hand, some expression in this hand.
So one
When I
has to
multiply
be
them, they're 0. What's that tell you?
One of the numbers has to be
Yeah,
0.
one of them has to be 0.
Yeah.
So 2x minus 14 is 0, or 3x minus 7 is 0, right?
Right.
Well, easy to solve this. This tells you x equals 7, or x equals 7/3. Okay?
Okay.
So you have to exclude 7 and 7/3. That was minus. Yeah. We have to exclude 7 and 7/3 from the domain, right?
Okay.
Okay? Now, 7/3 is already excluded. Why?
Because it's less than 5.
Yeah, very good. Got that right away. Okay? Most people wouldn't get that. That's very good. Keep working hard, you're gonna do well. Okay, so, since 7/3 is less than 5, right? But x equals 7. Isn't less than 5, so we add it. To the set of excluded values, right?
Right.
It's got to be excluded because if x equals 7, this thing is 0 and your denominator is 0, and you have an undefined quantity. Okay?
Okay.
So the domain is what? Well, it helps to draw this. Okay? You know, here we have x greater than or equal to 5. So that would do this, right?
Right.
But x can't be 7. Make sure that looks like a greater than or equal. So here's 5. It's included. 7 is not included. Okay? So we have an interval from here to here, but not including 7. And then everything from here on, but not including 7, right?
Right.
Okay, so there's a picture of the domain. Well, how do you put that in interval notation? Let's see if you can write that domain in interval notation.